Okay, class, good morning. I hope this works well for you. I'll try to put this on YouTube. Maybe you can view some of this before the test, and it'll help you get some of these questions with a little bit better understanding. So when we stopped yesterday, well, I guess on Wednesday, we talked about where we were going to decide to let X be the number of packages of bagels and Y be the number of packages for muffins. So we're going to say that X is our domain, so our number of packages of bagels is going to be our domain. So we need to figure out what domain, what the domain is going to be for a number of packages of bagels. Basically, what's the least and most number of packages of bagels that we could use. And the same thing with muffins, which will be represented by Y. So if we do that, then we have to kind of convert this. Instead of saying buy at least 12 bagels and 24 muffins, we're going to say buy at least 2 packages of bagels and 3 packages of muffins. So with that, then our inequalities would be X needs to be greater than or equal to 2, and Y needs to be greater than or equal to 3. Then when we try to make an inequality for the most that he can spend, that would be 250 X plus 350 Y needs to be less than or equal to 28. That's going to be how much he can spend. So when he calculates how many packages of each that he's going to purchase and multiplies by their costs of each, then he has to stay under that $28 amount. So when if we look at what the range is going to be, the least amount of packages of bagels we could have would be 2. So we know X has got to be greater than or equal to 2. But if we restrict that also over here on the range, so Y has to be greater than or equal to 3. Well, what's the most number of packages of bagels that I would need or that I would be able to buy? So if we change them into equations instead of inequalities, and we substitute, let's say we substitute 2 in the place of X. Well, we have 2.5 times 2 plus 3.5Y equals 28. Okay? So then if we solve for Y, we get 5 plus 3.5Y equals 28. Subtract 5 from both sides, we get 3.5Y equals to 23, and 2.8 or 23 divided by 3.5 comes up to 6 point something. So we can't buy 7 packages, and so we're going to have to be limited to 6 packages. Right here, when you divide by 3.5, you get Y equal to 6 point, I think it was 5 or so, or maybe it was 6.6. But either way, we can't buy 7 packages. That's going to cost too much. So we have to keep it less than 6 packages, or 6 or less packages of muffins when we buy only 2 packages of bagels. Now if we switch it the other way and say, well, what if we only buy the minimum number of muffins, 3? So we would say 2.5x plus 3.5 times 3 equals 28. Well, that becomes, when we solve that for X, what do we get? So when we solve that out, that means that 3.5 times 3 is 10.5. Subtract 10.5 from both sides, and we get 17.5. Divide both sides by 2.5, and we get 7. So X would be 7. So that's the most number of packages of bagels that we could buy. So that's how we would calculate our range and domain if we considered it only being able to buy entire packages of muffins and entire packages of bagels, and not being able to buy them individually. Number two, if the drama club's selling tickets, we have them create two variables. We'll say that A is going to be the number of adult tickets, and S is going to be the number of student tickets. And when we create the two inequalities, we are restricted, first of all, to 300 seats. So together, so the number of adult tickets plus the number of student tickets has to be less than or equal to 300. But we want to collect at least $3,630. So the dollar amount, which is going to be 15 for every adult ticket, so 15A plus $22 for every student ticket, 22S, we want that to become greater than or equal to 3,630. So that means we will make at least $3,630 off of all of our ticket sales. On number three, again, it wants the range and domain, so we need to specify which one's going to be X and which one's going to be Y. If we just go by the order that they're listed, then X would be the number of cups of flour, Y would be the number of teaspoons of baking powder. So if we have at most 24 cups of flour, then that means X has to be less than or equal to 24, and we can't have negative cups of flour, so the least we could have is 0. Y would be the same, have the same type of situation. We have at most 26 teaspoons, so that means the Y value needs to be less than or equal to 26, but again, we can't have negative, but we can have down to 0 teaspoons of baking powder. Well, number four, I'm not sure about the wording on this. It asks for inequalities. However, it doesn't give any restrictions. It just gives things that are equal to. So we're going to go with just two equations instead of two inequalities. First off, we're going to let X be the number of passengers at Hatfield, at Hartsfield, and Y is going to be the number of passengers at DFW. And the first thing we're told is that together they handled 106 million passengers. So together, that means X plus Y is equal to 106 million, 000,000. The next thing it tells us is that Hartsfield handled 18 million more than Dallas-Fort Worth. So that means that the difference between the two is 18 million. So Hartsfield had more, so we'll say X minus the smaller amount, which is Y at DFW, is equal to 18 million. Doesn't ask us to continue from there, it just wants the two inequalities. We don't have inequalities, these would be equations. For number five, if we look at these as equations, then we can find out where the lines intersect, and that would give us the vertices. So if we consider this to be y1, and that would be equal to negative 3x plus 7, and y2, the line there would be equal to 1/2 x, and y3 would be equal to negative 2. Then if we look for the vertex between y1 and y2, we could go y2, we'd go on our calculator and do the intersection. Put them both into, put y1 into y1 and y2 into y2, and or put them both into y equals, hit the graph button, and then do second calc at number 5, and then hit enter 3 times, and you should see the word intersection at the bottom of the page, followed by, or bottom of the screen, followed by the coordinates of the intersection. So when I did that, I got the intersection between y1 and y2 to be 2, 1. And then when I took out one of those and replaced it, let's say I put in the equations for y2 and y3, I got the vertex between those two lines to be -4, -2. And then when I did and graphed y1 and y3, I got the vertex between those two lines to be 3, -2. So that would be the corners of the figure formed by those 3 lines. We did the same process with number 6. We call this y1, y2, and y3. Then y1 and y2, they would have an intersection, and they would have a vertex of 2, 2. If we did the intersection between y1 and y3, we would get an intersection of -2, 4. And then if we did the vertex between y3 and y2, we would get a vertex of -3.6 and -0.8, as long as I didn't make an error somewhere in my calculations and typing it into the calculator. On number 7, I would first need to change these into slope-intercept form. I believe we would get this one to be y less than or equal to 2x plus 1. We'll call that a y1. y2 would end up being less than or equal to -x plus 4, and y3 would be greater than or equal to -1/4 x plus 1. So again, when I go through the same process as I did before in problems 5 and 6, the intersection between y1 and y2 would end up being 1, 3. The intersection between y1 and y3 would end up being 0, 1, and the intersection between y2 and y3 would end up being 4, 0. And that's just done by putting those into y equals in the calculator, graphing them, and using the intersection command, second calc 5, enter, enter, enter. It'll tell you the intersection between those two lines, as long as the intersection is shown on the screen. All right, good luck. We'll see you Monday. Tuesday.